Hello all. So in last classes we have seen what is the first derivative test and the second derivative test. Now both of this test can be used to find out where does a function have a relative maximum and a relative minimum. So in today's class we'll see a few problems on how to use the first and second derivative test to calculate the relative maximum and relative minimum. So the first question is find the relative extrema of f of x equal to 3x raised to 5 minus 5x cube. So we are given f of x. So first we'll find out f dash of x. So f dash of x is, so that will be 15x raised to 4 minus 15 x square. So that is 15 x square into x square minus 1, and f double dash of x is, so you'll get 60 x cube minus 30 x. So that is f dash and f double dash of x. So we will solve for f dash of x for the critical points. So the critical points are given by, so here the possibility that f dash of x is not defined is not coming. But f dash of x equal to 0 വരുന്ന points മാത്രമേ critical points വരുന്നുള്ളൂ. So that will be given by f dash of x equal to 0, because here first derivative is defined for all the x values. So that implies 15 x square into x square minus 1 is equal to 0. So that implies x will be equal to, so the roots are going to be, so you will get 0, 1 and minus 1. So these are the critical points. So let us look at what is the sign of f double dash of x at these points. So when you take f double dash of 1, f double dash of 1 will be equal to 60 minus 30. So that is greater than 0. So f double dash of minus 1 is minus 60 plus 30, which is negative, and f double dash of 0 is going to be equal to 0. So clearly 1 and minus 1. So 1 is going to be a relative minimum and minus 1 is going to be a relative maximum. So we will get about the behavior of 1 and minus 1. So x equal to 1 is the relative minimum, and x equal to minus 1 is a relative maximum by the second derivative test. Now at x equal to 0, the test is inconclusive. So let us use the first derivative test for x equal to 0. Okay. അപ്പോൾ നമുക്ക് f dash കിട്ടിയത് 15x square into x square minus 1. So f dash of x is 15x square into, so I can write it as x plus 1 into x minus 1. Now let us look at what is the sign of f dash of x towards the interval towards the left and right of x equal to 0. So the second derivative test, so the second derivative test fails at x equal to 0. let's apply first derivative test at x equal to 0. So let us take the interval. So let me take the interval from -1 to 0. So f dash of x, that will be, so let us look what is the sign of that. So let me take the interval 0 less than x less than 1 also. So you have, okay, let me write here the function. So that is 15x square into x plus 1 x minus 1. So here let me write the sign of f dash of x. So -1 നും 0യ്ക്കും ഇടയ്ക്ക് എടുക്കുമ്പോൾ first term x square, that is going to be positive, and x plus 1 is going to be positive ആയിരിക്കും, and x minus 1 is going to be negative. So positive രണ്ടെണ്ണം positive ആണ്, ഒരെണ്ണം negative ആണ്. So the sign of f dash is going to be negative in the interval -1 less than x less than 0. And when you take 0 to 1, 0 to 1 il x square positive ആണ്, x plus 1 positive ആണ്. അതുപോലെ 0 to 1 il x minus 1 negative ആയിരിക്കും. Okay. So this is positive, positive ആണ്, the third one is negative. So therefore the overall sign of f dash of x is going to be negative. So therefore at x equal to 0, f dash of x does not, so let us write, so f dash of x does not change sign in an interval containing x equal to 0. So therefore by first derivative test, x equal to 0 is neither a maximum nor a minimum. So therefore we'll have a relative maximum and minimum at the points -1 and 1, and at x equal to 0 it is neither a maximum nor a minimum. So that is the first question. So let us do one more problem. So the second question is, so find the relative extrema using both first and second derivative test. So the question is f of x equal to 1 plus 8x minus 3x square. So let us calculate the derivatives. So f dash of x is 8 minus 6x, and f double dash of x is minus 6 varum. So f dash of x, so first derivative is defined for all x values. So critical point is given by equating f dash to 0. So the critical point is, so you will get, it's given by f dash of x equal to 0. So that implies 8 minus 6x equal to 0. So you will get x equal to 8 by 6, so which is equal to 4 by 3. Now f double dash of 4 by 3. So f double dash of x is equal to minus 6 for all values. So f double dash of 4 by 3 is also minus 6 less than 0. So therefore we can conclude by second derivative test about the point x equal to 4 by 3. So therefore by second derivative test x equal to 4 by 3 is a relative negative ആണ് അപ്പോൾ relative maximum ആവും. So that is a relative maximum. And now let us use the first derivative test. അപ്പോൾ first derivative test again f dash of x is 8 minus 6x. So that will be equal to 2 into 4 minus 3x. Okay, or let me write it as 8 വെളിയിൽ എടുക്കുമ്പോൾ 8 അല്ല 6 വെളിയിൽ എടുക്കുക. Okay. So that is minus 6 into x minus 8 by 6, which is 4 by 3. So now x equal to 4 by 3 is a critical point. So when you take x equal to 4 by 3 on the interval above 4 by 3 x minus, so here x minus 4 by 3 will be greater than 0. So therefore on this portion f dash of x will be less than 0. When x is less than 4 by 3 the negative out. So negative into negative. So f dash of x will be greater than 0. So function changes from, so f dash, so function is changing from increasing to decreasing. So therefore you will have a relative maximum at the point x equal to 4 by 3 by the first derivative. So f dash of x changes from positive to negative. So therefore by first derivative test f of x has a relative maximum at x equal to 4 by 3. So that is the answer using the first derivative test. Now let me give you an exercise. So please try this by yourself. Again the question is same. Find the relative extrema using both first and second derivative test. So the function is x raised to 4 minus 12x cube. So find relative extrema using first and second derivative test using both. So work out this problem. So we will stop with this for today. Thank you.